Hey guys, this video is going to be about the different types of light emissions. So, the different kinds of things that allow us to see. That sounds kind of dumb, but like the things that emit photons. A photon being a light particle. Well, a light particle wave. It's a particle wave, but we're not getting into that right now. But it is a particle wave. It's really cool. Not what I want to talk about though. Types of light emissions. So the different kinds of light, we have natural light, which is the sunlight, which is a very good way to light your room when you're trying to teach. It is also a good source of heat, though. That's also like most of our light comes from the sun, but that's our natural light. We also have like artificial light, an example being combustion, which is the process, well, we'll get more into this later, but the process of like fire, things being combusted, but it's a whole thing. And also white light, which thanks to our pal Newton, we now know is all of the colors, which is really cool. We ever see the Dark Side of the Moon poster? It's also on the wall there. That is the process of white light going in through a pyramid, you know what I mean, a prism, and all the different colors of light coming out. That was all Newton. That is what optics is, by the way. Well, not really, but like optics, that is a big part of optics, is the way that white light works, which is really neat. We also, those are the types of light. But I want to go into the types of light emissions. I don't really know what I'm going to do with this whiteboard, because it's kind of a talky lesson. So I'm just going to kind of walk around. So, the first kind of thing I want to talk about is astronomical objects. So, when I say astronomical, some people will think huge. What I think of, and what I hope you will think of, is space. Actually, I got this new poster for little things. My space poster. And I'm wearing my NASA shirt, so how fun. Space, astronomical, astros, space. So this is like our sun. That's a big form of astronomical light. I want to talk about how the sun produces light. Our sun started out as a hydrogen atom, which was the first element on the periodic table, and then the hydrogen atoms collide with a helium ion. Well, they're ions, but the hydrogen ion combines with the helium ion, and what happens is a fusion reaction, which is like, it's like a nuclear reaction, and that's all that's happening. It's huge. Our sun is huge. We can't envision how big our sun is. It can fit about 1.3 million Earths inside of it, so it is a big ball of burning gas that gives us most of our heat and most of our light. Well, pretty much all of our heat. Yeah, most of our heat and most of our light. The next thing I want to go over is incandescent light. So you might have heard of incandescent light when we're talking about old light bulbs, like, but people don't usually like to talk about incandescent light in a good way, unless they're talking about as a way to also provide heat, because incandescent light is notorious for giving more heat than light. It gives about 95% heat and 5% light. Not the best if you were looking for light. So it gets really hot to the touch. This is, a lot of the old lights, incandescent light, boom. Fluorescent light, this is a chemical reaction of a hollow tube. So imagine a ceiling light, a hollow tube. I don't really know how it works, but like with two electrodes at the ends of them, there's like vapor involved, inert gas. There's a lot of phosphor involved, which is not really a good thing. It gives off a lot of UV light, ultraviolet light, a light we can't see, a light that comes from the sun. Also, UV light, but also it gives a lot of phosphor exposure. Next thing I want to go over is bioluminescence. Now, we know the definition of bio. Bio means life. So this is light within life, which may be hard to think of, like I think of an example, but I always like to think of an angular fish. I don't even know if that's how you say that, but the fish with the little lights coming out of their head, which is kind of neat. But yes, it's if I want to get all scientific about it, it's luciferin plus Phosphoresce. I don't know. I think those are two chemicals reacting together to make light. Next thing I want to go over is Triboluminescence. This is when something is changed or mutated to create light. A good way that I like to think about this is, I found this really cool. I used to do this as a kid. You take lifesavers and you like crush them in the dark, and they will like send out sparks of light, which is really cool. Yeah, Triboluminescence. So that's a good way to think about it. And also quartz crystals. Chemiluminescence. A very good way to remember this is chemistry, like chemical. Chemiluminescence. We can tell it as a chemical reaction. This is like glow sticks. You break them, shake them, and they glow for a while. Now, phosphorescence. This is absorbs UV light, so it will absorb light from the sun, usually, because that's what the sun gives off, UV light. And it will store it for a while and let it glow. So like this is like our glow in the dark things, our glow in the dark stickers, things they have to hold up to the sun for a little while and then they'll glow in the dark. So that's phosphorence. And then next is combustion, which is really actually kind of cool. Things being burned, combustion. But one thing that's neat about combustion is it is imperfect. So if you had your fire, right? You have a fire. This is my wood. Okay. And you have your fire going. You're burning the wood, right? But at the end of that fire, you don't just have nothing left. You have ashes. So the ashes of your wood. But you also, during the whole fire, had smoke going off. So combustion makes light energy and heat energy. It is on the other side of the scale is infrared light, but it also leaves stuff behind. So that is combustion. But there's another thing which you probably won't need to know, but I think is awesome. It's called annihilation, which is basically perfect combustion. If combustion were to have happened without anything left over. And there's not a lot of examples of this, but my favorite example is antimatter versus matter, which I'm going to make another video on because that is a whole other ball game. Really cool. I don't know much about it. But antimatter is a particle that has everything opposite to matter. And when they touch each other, they annihilate each other, which is the scientific word, annihilation. There is nothing left over. Everything is turned into energy. That's Einstein's E equals mc squared, which is really neat. Anyway, the last thing I want to go over is light-emitting diodes, more so known as LED lights, which is a lot of our lights now are light-emitting diodes. This is made possible by a semiconductant inside of something, like a filament, a semiconductant material, and an electrical charge sent through it, which produces our light. All fun and dandy. That's our types of light emissions. Fun. Thank you for watching.